Hi, 8th grade. Okay, so this morning we're going to do a quick review for our benchmark. So, looking at the first two problems, what form are these two numbers in? They are in standard form, so I need to convert them to scientific notation. So I need to convert them to a number times 10 to an exponent. So let's look at this first number right here. Where is the decimal in this number? It's a whole number. And my decimal's right at the end. So I need to move this decimal so that I will have a front number between 1 and 9. Where can I put this decimal so that the number becomes between 1 and 9? I can put it between the 4 and the 5. How many times do I have to move the decimal to get there? Move it 1, 2, 3, 4, 5 times. So I have 4 and 5, 6 times 10 to what power? Is it going to be to the 5th power or to the negative 5th power? It's going to be to the positive 5th power because it's a really big number, so that means we're multiplying it by 1, 0, 0, 0, 0, 0. So this is a big number. All right, what about this one? Is this going to be a big number, or is this a big number or a small number? It's a really, 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 really small number, so we're going to have a negative exponent. I'll just write NEG to remind myself. All right, so now where does this decimal need to go so that this number is between 1 and 9? Between the 7 and the 8. How many times do I have to move the decimal to get there? 1, 2, 3, 4, 5. I have to move it 5 times. So I'll have 7 and 89 hundredths times 10 to what power? Remember that my exponent is going to be negative, and I had to move the decimal 5 times, so it'll be to the negative 5th power. Now we're doing the opposite. We have two numbers in scientific notation that we need to convert to standard form. So looking at our first number, 5 times 10 to the 4th, is this going to be a really big number or a really small number? It'll be really big because my exponent's positive, so I'm multiplying it by a really big number. So I need to take my decimal and make it really big by moving it to the right 4 times. What do I put in those spaces? I put zeros. So I'll have 5 with 4 zeros. Make sure you just don't add your zeros because sometimes it won't just be adding that number of zeros. If it was 5.1 or 5.2, you would have had a 2 there instead. But in this case, it's just 50,000. In this one, I have 2 and 1/10 times 10 to the negative 3rd. Now it's going to be really small, so I'm going to move it to the left. 3 times. 1, 2, 3. And then I'll put my decimal where I've moved it. Remember, I'm moving my decimal, so you always put the decimal where it ends up. And I put zeros in the place, and then 2, 1. So it'll be 0.0021. All right, now we are doing operations with scientific notation. So first we have multiplication. When we're multiplying, do our exponents need to be the same? No, because that just means that we're lining up place value. When we multiply, we don't have to line up place value. So first I'm just going to start by multiplying my whole number. 7 times 9 is 63. And then when I multiply my tens, what do I do with my exponent? I add my exponent. Think back to exponent properties. So it'll be 63 times 10 to the 14th. Is this number in scientific notation? No, it's not. I need to make this one smaller and then make this one bigger. So I'll have 6 and 3/10 times 10 to the 5th. What do I do when I am dividing in scientific notation? I can do the same thing. I start by dividing my whole numbers, 3 divided by 8. If you do this out, you'll add top in, bottom out. 8 goes into 30 3 times. Make sure you bring your decimal up top. If you keep dividing, you'll end up with 0.375. And then with our tens, we subtract our exponent. This 10 at the bottom doesn't have an exponent though. What exponent can I put there? If it's just 1/10, that's 10 to the 1st power. So I'll have 4 minus 1, which is 3. So 0.375 times 10 cubed. Is this number in scientific notation? No. So I need to move the decimal 1 time. So I have 3 and 75 hundredths. Did I make this number smaller or bigger? I made it bigger, so I need to balance it out by making this number smaller. So it'll be times 10 squared, because I borrowed a 10 from 10 cubed, so my number got smaller. All right, now when we are adding and subtracting, do our exponents have to be the same? Yes, because when you add and subtract, you line up place values, so your exponents do have to be the same. So I want to change my smaller one. I need to make it bigger. It needs to get bigger by 3, which means I need to make this smaller by moving the decimal 3 times. In a whole number, the decimal goes where? It goes right behind the 4, so I need to move that over 3 times. So I'll have 7 times 10 to the 7th plus 0.004 times 10 to the 7th. All right, now looking back at your worksheet, you have one more subtraction problem to do. For this problem down here, this is multiplication, so it's easy. You just need to first convert that front number into standard or into scientific notation in order to multiply. Or you can multiply it out like this, but it's easier if both numbers are in the same form. And lastly, you have this problem right here. A conservative exponent of the number of stars in the universe is 6 times 10 to the 22nd power. The average human can see about 3,000 stars at night with his or her naked eye. About how many times more stars are there in the universe compared to the stars a human can actually see? All right, so we have a certain number of stars in the universe and a certain number of stars a human can see. How many times more stars? What operation are we doing? We're seeing how many times, so we're going to be doing division. So I'm going to take my bigger number, which is 6 times 10 to the 22nd power, because this is a huge number. You'd have to move that decimal 22 times. And then we're dividing by 3,000. Are both my numbers in the same form? No, so I need to get them in the same form. Because this number is so big, we don't want to change that one into standard form, so it's easier to just make them all into scientific notation. So 6 times 10 to the 22nd power divided by 3. How many times do I have to move that decimal to get it to a number between 1 and 9? 3 times. So it'll be 3 times 10 to the 3rd. Now you're doing division, so you can divide your first numbers, 2, and then you just subtract your exponents. 2 times 10 to the 19th power. All right, guys, I know we're all going to kill the benchmark today. You guys are so ready, so just stay confident. Make sure you take your time and check your work because it's really easy to make little mistakes with scientific notation. Good